Hello, my name is Serene, and this is my video explanation for assignment 2 of KT14203 Computer Architecture and Organization. In this video, I will walk through about my solution for all 4 questions. Okay, so for question 1 involves a 12-bit main-coded word with 8 data bits and 4 parity bits. The received bit sequence is 1011, 1110, 0111. I first map each bit to its position. From position 1 to 12, position 1 to 4 are parity bits P1, P2, P4, and P8, and the remaining positions hold the data bits. To detect the error, I calculate 4 check bits using XOR. C1 covers odd positions 1, 3, 5, 6, 9, and 11. And XOR, those received bits give 1 XOR 1, XOR 0, 1 XOR 1, XOR 1, XOR 0, we will get 0. And C2 recovers the position 2, 3, 6, 7, 10, and 11. And XOR, those give number 1. And for C4, covers position 4, 5, 6, 7, and 12. XOR those give number 1. And C8 covers position 8, 9, 10, 11, and 12. And XOR those give number 0. So the syndrome is C8, C4, C2, C1, which is equals to 0, 1, 1, 0. Since this is not 0, 0, 0, a single bit error has been detected. And for part B, I converting the syndrome 0110 from binary to decimal, and it will equals to 6. So the erroneous bit is at bit position 6. So to recover the original data, I flip the bit at position 6. So the data bits will be original 8-bit data message is equals to 10110101.
This meeting is being recorded.
Now we proceed to question 2. And for question 2, x equals to negative 5 is the multiplicand m, and y equals to negative 4 is the multiplier q. So I need to express both in 5-bit 2's complement. So for m is equals to negative 15. Positive 15 in binary is 0, 1, 1, 1. So the m is equals to 1, 0, 0, 1, and negative m is equals to 0, 1, 1, 1, 1. For q is equals to negative 4. Positive 4 in binary is 0, 0, 1, 0, 0. And so we do the 2's complement. So the negative 4 will be 1, 1, 1, 0, 0. We proceed to the part B. And so for the part B, for more understanding, I have drawn the flowchart for me to do more easier to answer the question. And now we proceed to the solution.
This meeting is being
now
recorded.
We move on to our solution using the Booth, this is the Booth algorithm table. And so for initial, I initialize the A is equal to 0, 0, 0, 0, 0, and the Q is equals to 1, 1, 1, 0, 0, and the Q minus 1 is equals to 0. So for the step 1, since the Q0 is equals to 0 and the Q minus 1 is equals to 0, this is a case of 0, 0, so no operation and arithmetic shift right. So our A will be 0, 0, 0, 0, 0, and our Q will be 0, 1, 1, 1, 0, and Q minus 1 remain 0. Now we move on to step 2. Step 2, because the Q is 0 and the Q minus 1 is 0, so no operation, then we will do the arithmetic shift right. So our A will be 0, 0, 0, 0, 0, and our Q will be 00111, and our Q minus 1 also remain. And so that we move on to the step 3. Step 3, since our Q is 1 and our Q minus 1 is 0, so the case is 1, 0, then we will do the calculation. A is equals to A minus M and equals to A plus negative M, which is 00111 plus 10001. So we will get an answer of 01111 for our A. And then for Q is 00111, which remain. And after that, now the case will become 1, 0. The Q is 1 and the Q minus 1 is 0. So we will do the arithmetic shift right. So our A will be 00111 and our Q will be 10011. And for the step 4, our A will be 0011 and our Q will be 11001 and our Q minus 1 will be 1. And for 5, since our Q is 1 and our Q minus 1 is 1, this is case of 1, 1. Then we will do the arithmetic shift right. So our step 5, our A will be 00001 and our Q will be 11100. So our final answer will be 00001 and 11100. So this is a positive answer for negative 15 times negative 4. Yeah.
This meeting is being recorded.
Okay, now we proceed to question 3. Question asking to frustrate solving divide by negative 5 using 4-bit word and the restoring division algorithm. So to set up, divisor n is equals to 0, 5 equals to 010, and the dividend 2 equals to 7 equals to 011. So initially where r is equal to 0000. So the algorithm runs for n equals to 4 steps because 4 bits of dividend. So as the question show, as the same as the question show, I draw the flow chart so that we can more understand. So for me to more understand the flow how it's going.
This meeting is being recorded.
Okay. Okay. Now we proceed to solution part. So initially we assume that the accumulator is equal to 00000 and the dividend is equal to 0111 and the divisor is equal to 0101 in the initial state. And in step 1, we need to shift left. So the A is also the same, is equal to 0000. And dividend, the number is shift to the left. So it will become 111, brings an unknown number. And for this negative m, I do the negative m because of maybe the negative m will use in the after step. Yes. So I do the negative m first. And after that, we need to do the a minus m and insert the value into the a. So a minus m is also equal to a plus negative m. So as we already have a negative m, then we put that into the solution. So we will get 1011. And since our size of accumulator is 1, then we will put the 0 into the 1110 and we will restore again the 8. And step 2, we will shift left again. So our A will be 0001 and our Q will be 1110, brings an unknown number. And then we will do again an A minus M and store value. So we will get 1100. And as our sign of accumulator of A is 1, so the 0 is stored into the Q. So we will become 1100 and we will restore again the A, which is 0001. And after that, in step 3, we need to shift left again. So our A will be 0011
and our string will be 100 with an unknown number. So when a minus m, we need to do the a minus m is restore the value. So our a will be 1110. So as our sign of accumulator is 1. So 0 is stored into the queue. So it will become 1000. So we'll restore a again. It will become 0011. Okay, after that we move on to the step 4. In step 4, we need to shift left again. So 0111 and the queue will become 000 brings with an unknown number. So we do again the a minus n and store the value into the a. So it will become 0010, which brings a 1 in front of this, but we only have 4 bits, so we ignore it. So as our um, sign of accumulator is 0, so we will put the 1 in the last value. So it will become 0001 for our key and keep the A value, which is 0010. So our question will be 0001 and our remainder will be 0010. Okay, and since um before we do this restoring division algorithm, we need to assume that the dividend and the divisor is positive. Then after that, we only find the real value. So since the dividend D is positive, which is 7, and divisor is negative, which is negative 5, so the question is negative, which do the 2 complement and we will get 1111 for our question. And remainder is positive, which is equal to 0010. That's all for question 3. Now we move on to question 4.
This meeting is being recorded.
Okay, now we proceed to question 4. Question 4 involves a 16-bit load instruction with output 0x12, register field R4, and address field 0x3x6. I need to find the operand value for 4 addressing modes. So for part A, immediate addressing. So in immediate addressing, the address field itself is the operand. So the operand value will be 0x3c. So no memory access is needed. The value comes directly from the instruction. And after that, we will go to the part B. Indirect addressing. The address field points to the memory location that holds the operand. Address field is equal to 0x3c, and memory of 0x3c is equal to 0x8e. So the operand will be 0x8e. And for part B, in register indirect addressing, the register specify R4 holds the address of the operand. So R4 is equal to 0x4d, and memory of 0x4d is equal to 0xa1. So the operand will be 0xa1. And after that, we'll go for the part B. So in part B, in the indirect addressing, address field 0x3c points to a memory location which itself contains another address, and that second address points to the actual data. So the address field is equal to 0x3c points to a memory location of 0x3c, and which is equal to 0x8e. So since um since the value at memory 0x8e is unknown, so the operand value by applying indirect addressing will be 0x8e. That's all for my explanation. Thank you.